Example 2 is another question that we give a special name. I call these ones multi-revolution questions. And we'll find out why in a bit. It starts off sounding a lot like questions that we've done before. Solve, sine, blah, 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 and between 0 and 2 pi. But what's different is instead of having just sine of theta or just sine of x, there's a 3x inside. So if we think graphically, when we've had a number inside as a b value, that changes our period. That 3 would be a horizontal compression by a factor of 1/3. And so it squishes your sine graph. So normally between 0 and 2 pi you have one period. But since you're squishing it by a factor of 1/3, you would have 3 full periods between 0 and 2 pi. So what we're going to do is we're going to solve this, or start to solve it, as if it just said sine theta equals 0 between 0 and 2 pi for theta. But then we're going to make the realization that it's not just sine theta, it's sine 3x. So the first thing we're going to do with our starting with the 3x is say, if I know that x is supposed to be between, I know that x is supposed to be between 0 and 2 pi, then what would 3x's be between? Well, if 1x is between 0 and 2 pi, 3x's would be between 0 and 6 pi, because we've multiplied by 3. It's like if I got you to pick a number between 1 and 10, and you got the number in your head, now I tell you to multiply it by 3. Everybody's numbers now will be between 3 and 30, because you started with a number between 1 and 10, but when you multiply it by 3, now your numbers would be between 3 and 30. So we're starting with x between 0 and 2 pi, but when you multiply x by 3, that means 3x's would be between 0 and 6 pi. So again, if this was just, and don't write this part down, if this was just sine theta equals 0, and you were solving for it, is your y-coordinate ever 0? We're not going to do this to the nearest hundredth. We're going to do exact answers. When is your y-coordinate equal to 0? When theta is 0 and pi and 2 pi. And that's how you would solve this question if it said sine theta equals 0. But what we have is we have sine 3x equals 0. But you go about solving it the same way. When it was sine theta equals 0, your next step you said theta equals. Since it says sine 3x equals 0, you say, well, 3x could equal. It could equal 0, pi, and 2 pi. And that would be one time around your circle from 0 to 2 pi. However, 3x's is from 0 to 6 pi, which means you're going 3 full times around the circle. Hence the name multi-revolution, because the 3x means you're going around the circle 3 times. So the first time around the circle I get 0, I get pi, I get 2 pi. The second time around the circle I'll also get 3 pi and 4 pi. So I have to add those. The third time around the circle, I'm going to get 5 pi and 6 pi. So I'm going to add those as well. Ooh, just looking at what I did, I made a tiny little mistake in my work from what the question said to what I wrote down. Can you notice the mistake that I made? That's right. If we look at the question, 2 pi is not included, so I should erase this equal sign here, which would erase this equal sign there, which means that 6 pi is not included, so I have to take that one out. So the multi-revolution means that for solving for 3x, we had to go 3 times around. Now that we've gone 3 times around, we can now solve for x. Well, if 3x was equal to 0 pi, 2 pi, 3 pi, 4 pi, 5 pi, then 1x would equal, and we'd have to divide each of those by 3. So 0 divided by 3 is still 0. I'd have pi divided by 3, 2 pi divided by 3, 3 pi divided by 3, 4 pi divided by 3, and 5 pi divided by 3. And if we look at all of our final answers for x are all between 0 and 2 pi. Because 2 pi is the same as 6 pi over 3. And notice that our biggest answer is less than 6 pi over 3. All of our answers are between 0 and 2 pi. These multi-revolution questions are a little bit different and hard to get used to at the beginning, so we're going to do more than one example. Solve for theta. Cos 2 theta is equal to negative root 3 over 2, and we want to solve this for theta between 0 and 2 pi. So again, we can recognize a multi-revolution question whenever it's solving and there's 2 theta or 3 theta inside of sine or cos. The first thing that we're going to do is look at the domain that we're solving from 0 to 2 pi, and say, well, if 1 theta is between 0 and 2 pi, then 2 thetas would be between 0 and 4 pi. In other words, 2 thetas is twice around the circle. Next, we solve it like normal. Is root 3 over 2 on your pi plate for your x coordinate? What family? Our family would be pi over 6 family. If you wanted to, you can even write your reference angle. This is a little bit weird to write your reference angle because it's your reference angle for 2 theta, but your reference angle is a pi over 6 family. But since cos is negative, what quadrants would it be in? Quadrant 2 and quadrant 3. Of course, quadrant 2 and quadrant 3 is just once around your circle. On the second time around the circle, what would be coterminal with 5 pi over 6? And how do you find that? So if I'm starting at 0 here, I go all the way around once, and then go to 5 pi over 6. What would that angle be? And how would you find it? So if I'm trying to find something coterminal with 5 pi over 6, basically what I need to do is I need to go plus 2 pi one full time around to get there again. How do you add 2 pi to 5 pi over 6? Well, you'd need a common denominator, adding fractions. So one of the things you're going to get good at is changing 2 pi to different fractions. 2 pi will be what over 6? Yeah. 2 pi would be 12 pi over 6. So when I add 2 pi to 5 pi over 6, I'm going to get, just add 12, 17 pi over 6. 2 pi plus 7 pi over 6 will be 19 pi over 6. And so for 2 theta, we've solved it between 0 and 4 pi. If you want to solve for theta now, I would have to take each of those answers and divide them by 2. Now, 5 pi over 6 divided by 2, it might be easier to think about what's equivalent to dividing by 2. Dividing by 2 is the same as multiplying by half. And if I take a fraction like 5 pi over 6 and multiply it by a half, that's just going to multiply my denominator by 2. So I'll have 5 pi over 12. When I divide that one by 2 or multiply by half, 7 pi over 12, 17 pi over 12, and 19 pi over 12. Notice that our final answers are between 0 and 2 pi. 2 pi would be 24 pi over 12. And our biggest answer is less than 24 pi over 12. So again, we start by looking at our domain and adjusting it for what our multi-revolution is. In this case, it was 2 theta. Solve for 2 theta from 0 to 4 pi. Then we divide it by 2 to get theta by itself. We'll do one more. Solve for theta. Sine of 3 theta is negative root 2 over 2. But this time we're solving for theta between negative pi and pi. So what happens if you start with a domain different than 0 to 2 pi? Well, if 1 theta is between negative pi and pi, that would mean that 3 thetas is between negative 3 pi and 3 pi. And so we start by solving this like normal. If I was solving a sine 3 theta equals root 2 over 2, I would say that 3 theta is equal. Well, what family do I have sine equal root 2 over 2? Pi over 4, or 45 degrees. And which quadrants would I be looking in? Sine is negative, so I'd look in quadrant 3 and quadrant 4. So I would get 5 pi over 4 and 7 pi over 4. And that would be one full time around. But what am I looking for? I'm looking for negative 3 pi to 3 pi. So I'm going to think about this as positive angles and negative angles. My positive angles, I have to look between 0 and 3 pi. So we've already done between 0 and 2 pi. I need to go another halfway around. When I go from 2 pi to 3 pi, do I get any more answers? No, because my answers are in quadrant 3 and quadrant 4. So when I go to 3 pi, I get quadrant 1 again and quadrant 2 again, but that's not coterminal with those answers. But I also have to think about my negative angles. So when I go once around in the negative direction, I'm going to get coterminal with 7 pi over 4. That'll be negative pi over 4. And coterminal with 5 pi over 4 will be negative 3 pi over 4. So 2 ways you can think about this. How did I get negative pi over 4 and negative 3 pi over 4? My favorite way to think about it is when I'm going in the negative direction, I count my quadrants like negative quadrants. This is like negative quadrant 1 is quadrant 4. Negative quadrant 2 is quadrant 3. Negative quadrant 3 would be like quadrant 2. So when I'm looking at negative quadrant 1 in quadrant 4, whatever angle it is the same as the pi over 4 in quadrant 1. My pi over 4 in quadrant 1 is pi over 4, so my negative pi over 4 in quadrant 4 will be negative pi over 4. When I think about quadrant 3 in the negative direction, it's like going to the second negative quadrant. So what's my pi over 4 in quadrant 2? Is 3 pi over 4. So my second negative pi over 4 quadrant would be negative 3 pi over 4. That's one way that I think about negative angles. Another way you could think about negative angles is if I go from 5 pi over 4, or I went from this one to this one. If I will go from 7 pi over 4 in quadrant 4 to negative, if I want to go back one direction, I would have to subtract 2 pi. And 2 pi is the same as 8 pi over 4. So I'd have to subtract 8 pi over 4. 7 pi over 4, subtract 8 pi over 4, gives me negative pi over 4. 5 pi over 4, subtract 8 pi over 4, gives me negative 3 pi over 4. And that's solving once in the negative direction from 0 to 2 pi. Sorry, from 0 to negative 2 pi. But my domain says I need to go to negative 3 pi. So if I went another halfway around, would I hit those angles again? Yes. So they will also have negative 9 pi over 4. I subtracted another 8 pi over 4 from pi over 4, and negative 11 pi over 4, subtracting another 8 from 3 pi over 4. And that has solved 3 theta between negative 3 pi and 3 pi. From here, now if I want to solve for theta, I'm going to have to take each of those answers, divide it by 3. Dividing by 3 is the same as multiplying by a third. I will get 5 pi over 12, 7 pi over 12, negative pi over 12, negative 3 pi over 12, negative 9 pi over 12, and negative 11 pi over 12. All right. Try question 10 for part A. I know that the answer key has the answers as decimals. For part A, I want exact numbers. For part B, it's not on your unit circle. It's not on your pie plate. So then you'll have to use a reference angle and figure it out with reference angles the same way.